Two-variable data. Two-variable data is also called bivariate data. Think of that prefix of bi means two. With bivariate data, there are two sets of related data that you want to compare. So here's our first example of bivariate or two-variable data. We have an ice cream shop keeps track of how much ice cream they sell versus the temperature on that day. So this table shows 10 days of data. The two variables here are temperature and ice cream sales. So we can create a scatter plot by plotting the points where temperature is the x variable and sales is the y variable. So each of the 10 data points now can go on a graph and can create this scatter plot. Notice again, our x variable of temperature is on the x-axis, our y variable of ice cream sales is on the y-axis, and we can see our 10 data sets or data points are marked with these green points. Now, what did the scatter plot show us? Right? Analyzing, look at and think of the two variables and think about comparing them. Using the scatter plot, it is easy to see that, well, we can see that the warmer weather leads to more sales. As the temperature increases, your ice cream sales increase, and vice versa. So this data has certain behavior, and in a scatter plot, you can see that it will either be linear or nonlinear. Linear is where your data points are forming almost a line pattern. You can almost visualize the line on the scatter plot, where most of your data points would line up, versus nonlinear is they're not lining up. They're forming more of a curve or no shape at all. And these are two other examples. These are scatter plots that are nonlinear as well. Again, you can't really imagine a line that would be good for all the data points. You have to curve at some point. And if a scatter plot is linear, it can be described then in three ways, where it has a positive association. You can see from left to right, it's almost like you have an increasing line or a positive slope. A negative association, where you have, reading from left to right, a decreasing line, it has a negative slope. Or no association, where you have a zero slope. You have almost this horizontal line. So here's a second example for a scatter plot. We have data for 10 students' math and science grades are shown in the table. It says to plot the points to create a scatter plot. So here the two variables we're comparing is a student's math grade and a student's science grade. So we'll consider the math grade as our x values and the science grade as our y values, and we'll plot our 10 ordered pairs to create the scatter plot. So here is those 10 points plotted. Here's what our scatter plot would look like, so that now we can answer questions and analyze and interpret what the data means in terms of comparing a student's math grade to their science grade. Now, when looking at scatter plots, we also can make predictions about data points that we don't have. So here we have a scatter plot that's comparing a boy's height and weight. What kind of predictions can you make from looking at the graph? So think about the two variables you're comparing. Think about what is the association and behavior of the scatter plot points that you do see, and see what can you predict about the future data plots or the future behavior of a boy's height and weight. Well, looking here, we can predict a boy's weight given his height or a boy's height given his weight. If we have one variable, we can predict the other. We can also see the type of relationship that a boy's height and weight has by looking at the behavior of the scatter plot. So here is another example where we have survey data, where we have a student wanted to find out if there was a relationship between the number of hours a person exercised in 1 week and their resting heart rate. So 15 people were surveyed, and the table at the right shows the results. So we can take these results and we can plot them on a scatter plot. We can think the number of hours is our x values and the resting heart rate is our y values. So we'll label the x-axis the number of hours and the y-axis the resting heart rate, and we'll plot these 15 data points. So here is our data points. Here's our scatter plot. And again, this is comparing the number of hours to the resting heart rate. So now looking at this scatter plot, here it is down here, we can then ask these questions. We can see, is there a linear relationship? If it is a linear relationship, is there a positive or negative association? And then we can predict, we can say, according to the scatter plot, does a person who exercises generally have a lower resting heart rate than a person that doesn't exercise? These are questions we're now able to answer using the scatter plot. And our answer will be that, yes, this is a linear relationship. We can imagine a line that goes through most of the data points, or most of the data points are around or surrounding or very close to that line. It would be a negative association because as our x values increase, our y values decrease, which kind of leads into the next question, because it's saying, does a person who exercises, so as the exercise increases, the resting heart rate decreases. So as you exercise more in general, you'll have a lower resting heart rate. So we can answer yes to that question. Now let's answer the same kind of questions but with different data. Here we have data from when Sandy wanted to find out if there was a relationship between the number of hours a student spent browsing the internet in each day and their math grades for the marking period. She surveyed several students and the results are shown in the table at the right. So if we want to make a scatter plot, we can think of the variables as our hours and math grades. So the variable of hours would be our x variable and our y variable would be our math grade. So our x-axis would be the amount of hours and our math grade would be labeling the y-axis. So here is our scatter plot. And here we can now look at the scatter plot and look at the behavior of comparing the amount of hours that a student spent on the internet and their math grade, and we can answer questions using the scatter plot. We can answer, is the scatter plot linear or nonlinear? Is there a positive or negative association? And then finally make our general conclusion about the math scores as more hours are spent browsing the internet. Well, this data is linear. We can imagine a line that's going through most of our data points, or most of our data points are around that line. It has a negative association because as x increases, the y values are decreasing, which directly affects our conclusion that if the x values are increasing, that means the more hours spent browsing on the internet by a student. If our y values are decreasing, that means the math scores are going to be lower. So the more hours spent browsing on the internet, the lower the math score a child or a student will have. Let's look at more examples where we already have the scatter plot. We have the table shows the average temperatures for the month of January in New Jersey from 2000 to 2009. And here is the scatter plot of those data points. We have the year is the x variable and the temperatures is the y variables. So looking at the scatter plot, is this data linear? Is there a positive association, a negative association, or neither? So we can see this is nonlinear data. There's no line that you can imagine that is all the data points are around, or they're not modeling or mimicking that linear behavior. So that means there's going to be no association. It's not positive or negative. So we can kind of conclude that the temperatures for the month of January for the different years doesn't really have, it doesn't increase as one increases, it doesn't decrease as one increases, it just is a random relationship. Now here we have a table that shows the average temperature by month for New Jersey. So not just for all of January for different years, but now by month, where we're assuming month 1 is January, month 2 is February, month 3 would be March, and so on and so forth, where month 12 would be December. And then we're taking that average temperature. So now make a scatter plot using that data. So we want to then answer and see, is that graph linear, and would there be an association, whether it be positive or negative, or maybe neither again. So here if we have our scatter plot, we have X will be the months and Y will be the temperatures for those variables. And we can see that this is again nonlinear. It looks like half the data was increasing. It could be almost a positive association, but the other half is going to be a negative or decreasing line. So if you combine both, we need it to be one or the other. It can't just switch. This is now creating that curved data, so it's nonlinear. So we have to see the association as a whole instead of just looking at piece by piece, but we can answer that based on the scatter plot.